We're solving problem 14 from the 2024 F equals MA exam. A bead of mass M can slide frictionlessly on a vertical circular wire hoop of radius 20 centimeters. The hoop is attached to a stand of mass M, which can slide frictionlessly on the ground. Initially, the bead is at the bottom of the hoop, the stand is at rest, and the bead has velocity 2 meters per second to the right. At some point, the bead will stop moving with respect to the hoop. At that moment, through what angle along the hoop has the bead traveled? So for this problem, we're going to use the conservation of energy formula stated up here. Now, first thing we want to do is find our change in height, because only then can we use trigonometric identities to find the degree measure in which the marble or the bead has undergone. So we can say that our initial kinetic energy, KE initial, well, this just directly corresponds to the kinetic energy equation 1/2 mv squared. Since we know that our initial velocity is 2, we plug that in here to get 2m, and that's our starting kinetic energy in joules, 2m joules. Now our new kinetic energy, this is going to be 1/2 times, this is going to be 2m now. The velocity, we're solving for the case when v over 2 is equal to 1/2, so this is just 1. So basically, our new kinetic energy has a magnitude of 1 m joules, 1 times m joules, whatever you want to call it. Now, this is crucial because the change in kinetic energy, delta kinetic energy, 1 m joules. So we have that. Now we know that we can use the potential energy equation, where potential energy is equal to mg delta h. This is what we're trying to find. Our delta h is what we want to find. So we can sort of plug g, or this is just 1m is equal to e times delta h, right? Since we know that g is 10, we could do m times 10 meters per second squared times delta h. We can cross out the m's and say that delta is equal to 1/10 or 0.1. We have that now. Well, now we can use trigonometric identities to really find the angle measure it has traveled, because we know the change in height. So we can sort of say that delta h is equal to radius of the whole entire circle in this case times 1 minus cosine of theta. Now we can easily plug in delta h as 0.1, and this is 0.1 meters, or meters, 1 meter. Now for r, well, you would say 20, right, because it's 20 centimeters. Well, this is actually not the case, because what we just solved for here, this 10 is basically implying, since this is the gravitational force, and the test wants us to use g equals 10. This 10 is actually, it's going to be the magnitude of objects falling at 10 meters per second squared. Since it's in meters, we want to convert the radius of the circle, which is in centimeters, to meters. So 20 centimeters, which is the radius of the circle, is 0.2 meters. So we have this equation now. And, well, we can just simplify this to cosine of theta is equal to 0.5. And taking the inverse of this cosine of that, we can find that our angle measure is going to be 60. So that is going to be our answer for this problem.